This video demonstrates how to create a kinetic energy of fission fragments calculator in Excel. Row 1 of your kinetic energy of fission fragments calculator must have the following 7 headers. Enter the products. Enter number of nucleons in products. Enter binding energy per nucleon in million electron volts. Subtotals of binding energy per nucleon in million electron volts. Grand total of fission fragments binding energy in million electron volts. Difference in binding energy between uranium-236 and fission fragments in million electron volts. And kinetic energy of fission fragments in million electron volts. Format columns D, E, F, and G to have no decimal places and a comma 1000 separator. Accomplish this by clicking on column D, then holding down the Shift key, then clicking on column G. Note that this highlights the columns. Right-click on any highlighted column, select Format Cells, select the Number tab, select the Number category, reduce the decimal places to 0, place a check in the box named Use 1000 Separator, comma, and click the OK button. Merge cells E2 and E3 into a single cell. Click cell E2, hold down the Shift key, then click on cell E3. On Excel's Home tab, in the Alignment section, click on Merge and Center. Duplicate this formatting for cells F2 and 3, as well as cells G2 and 3, by clicking and dragging the small green square in merged cells E2 and 3, and dragging it to cell G3. Notice that when you lift your finger off the mouse, Excel automatically merges and centers these cells. For this calculator, we will use strontium, symbolized by the letters SR, and xenon, symbolized by the letters XE, as the products that result from a fission reaction. In cell A2, type the symbol for strontium, which is SR. In cell B2, type 97, which is the number of nucleons in strontium. In cell C2, type 8.5, which is the binding energy per nucleon in million electron volts for strontium. In cell A3, type the symbol for xenon, which is XE. In cell B3, type 137, which is the number of nucleons in xenon. In cell C3, type 8.4, which is the binding energy per nucleon in million electron volts for xenon. In cell D2, type an equal sign. Then click on cell B2, then type an asterisk, then click on cell C2, then hit the Enter button on your keyboard. Notice that Excel calculates the answer to the formula, and also notice that Excel's formula bar displays the formula. Duplicate this formula for cell D3 by clicking and dragging the small green square in cell D2 to cell D3. Notice that when you lift your finger off the mouse, Excel automatically calculates the correct subtotal of the binding energy per nucleon for xenon. In the merged cells E2 and 3, type an equal sign. Then click on cell D2. Then type a plus sign. Then click on cell D3. Then hit the Enter button on your keyboard. Notice that Excel calculates the answer to the formula, and also notice that Excel's formula bar displays the formula. In the merged cells F2 and 3, type an equal sign. Then click on cell E2, then type a minus sign, then type 1794, which is the binding energy of a single uranium-236 atom. Then hit the Enter button on your keyboard. Notice that Excel calculates the answer to the formula, and also notice that Excel's formula bar displays the formula. In the merged cells G2 and 3, type an equal sign. Then click on the merged cells F2 and 3, then type an asterisk, then type 0.83, which is 83%, the percent of the fission fragment's binding energy that is transformed into kinetic energy. Then hit the Enter button on your keyboard. Notice that Excel calculates the answer to the formula, and also notice that Excel's formula bar displays the formula. Note that the finished calculator will work for any fission fragments as long as we know the number of nucleons and the binding energy per nucleon for each product.